Sorry about that. I will bring it to the top and the power becomes 4/3. Now I have to be careful here. I have several options. Here's one option. The cube root of 64 to the 4th. How come? Any exponential notation that has a fractional exponent is a radical, and vice versa. If it's a radical, it can be changed into an exponential notation with a fractional exponent. 4 is at the top, and the index is always the denominator. Now, one option would be to put in the graphing calculator, but if I don't get an integer, then I have to go back to the drawing board. So I have to change 64 into 2 to the 6th. How come? Well, 2 squared is 4. 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. But then I have to raise it to the 4th power. So first let's write the intermediate step, the cube root of 2 to the 6th, everything to the 4th power. And then I have the cube root of 2 to the 24. And this is really nice. I copy 2 and divide 24 by 3, and that's 8. So it's basically 2 to the 6 multiplied by 4. 256. Of course, you should check this with the graphing calculator because you don't want to miss points on a test. So yes, of course, I would put it in the graphing calculator exactly as I see it, as 64 caret 4/3. If I don't get 256, I'll go back to the drawing board and say, why didn't I? But if I get 256, I'm fine. I'm going to punch in 256 and move on. Simplify your answer time, 256. Again, here we worked on this problem together. It's the same problem we did in class, but with different numbers. 16 to 5/4 over 16 to 1/4. This is a piece of cake, right? I copy the base and I subtract. From 5/4, I subtract 1/4. I get 4 over 4, which is 1. And that's it. It's just a blink. And I just enter 16, and I'm done. There's nothing else. Good. Here I have to think. Here there is a little bit more work. So 2, 81 to 1 over 16, and everything to -4. As I mentioned a long time ago, first deal with the negative exponent. 2, 81, 1 over 16, and everything to the 4th power. So it's 1 over 2 to the 4th. We know it's 16. 81 to 1 over 16, I multiply the exponents, and I get 81 to power 1/4. But when you take the power 1/4 on 81, you will get 3. It's the 4th root of 81, and that is 3. And all I have to do is multiply 16 by 3. I get 48, and I'm done.
What?
Which part?
The part after you flipped it.
Which part of this is what?
Okay. You did step 1. I understand step 1 because it's negative exponents.
But then you understand 2 to the 4th, which is 16. Then you understand 81, and you have to multiply the exponents. When you multiply 1 over 16 by 4 over 1, you get 1/4.
Yeah, you lose right there. You lose me right there. I'm lost right there in that little section. So you say, okay, 4 times 4. Okay, 2 to the 4th is 16. And then
You copy the base and multiply the exponents. And this is a huge rule.
1/6. Okay.
You copy the base and multiply the exponents. This just needs a ton of practice. I mean,
yeah, I was gonna say I'm gonna practice more problems like this.
By now, this should be second nature. Because yep, so you copy the base and multiply the exponents. When you multiply 1/16 by 4/1, you will simplify, you get 1/4.
Mm-hmm.
A rational exponent means a radical. Which radical? It's the fourth root. The fourth root of 81 is 3. So all you have to do is multiply 16 by 3 to get 48. Is there a way of checking this? Yes, there is a way of checking this before you put it in. With the graphing calculator, you will enter from the very beginning 2 multiplied by 81 caret in parentheses 1/16. Don't forget to put parentheses again. Don't forget the caret. And don't forget in parentheses -4. It will give you a gibberish. But my 1/48 has to give me the same gibberish. Otherwise, math means nothing. So there is some sort of error here. Let me, because I entered 19.
Yeah, it's 16.
So the gibberish has to be identical. If it's not identical, something is off.
Let's see.
But this requires hours of work and reviewing the videos because we worked on tons of problems in the exponential rules. So this is 1 divided by 48.
Could we do another one that's just like that?
I'm not sure if we find one. Let's finish this and then we can create one. We had plenty of examples. We can go back and try to find another. I don't know. But let's finish this and then we'll go back. So this one is another very easy situation, but all you have to do is just use. Now, if you find another, you can stop me anytime. Okay, so here all you have to do is just realize that we can go back and forth and you multiply is 105 and you're done. There's nothing else to write. That's it. That's another 1 second problem. So we have to use the cube root. So that's 3 and this is 105. And that's it. Nothing. The same thing here. Because we are allowed to condense them because they are multiplied. 3x/5 and 5/x. So we write 3x/5 times 5/x. Simplify the x's, simplify the 5's, and the answer is the square root of 3. Again, another blink of a problem. All you have to do is simplify numbers.
I forgot to put the square root there. I got that one easy.
Okay, so here we have the square root of 3, and that's it. The same thing here. The cube root of -64 is -4. There is nothing to it, and then b. That's it. I don't even have to write anything. The cube root of -64 is -4. The cube root of b to the third is b. The index is 3. I don't need absolute value, ever. Now I evaluate. 25 plus 2 is 27. The cube root of 27 is 3. -29. -29 plus 2 is -27. So the cube root is -3. And the -252, I have no clue. I have to work on this because I don't know what this number is. So this one I will write in my notes. So this is page 6. So page of -252 is the cube root of -52 plus 2 is -250. Yes, I can use the calculator, but let me see what this is. So 250 is 25 and 10, and this is 5 and 5, and this is 2 and 5. So I can take the cube root of negative 125. So this is the same with the cube root of negative 125 multiplied by 2. The cube root of negative 125 I know is negative 5. And the cube root of 2 has to stay as the cube root of 2. So putting this one in the graphing calculator would not have helped, because it would have been a gibberish and not been able to do anything with it.
I only use the calculator to verify that the answer is correct.
Of course, you should always do that. Absolutely. So then here I will enter negative 5, and then the cube root, and 2. And that's it. The domain, x plus 8 has to be greater than or equal to 0. That's a must. So in a function that is a radical function, meaning with the index that is even, x plus 8 has to be strictly greater than 0. See, greater than or equal to, not strictly, greater than or equal to 0. So then the domain is negative 8 to infinity. Another blink, effect, really, just a blink. So here it says interval notation, negative 8, comma, infinity, with a parenthesis, done. Good. For the given function, determine the domain. So let's discuss this for a moment, because I saw, so this is the square root of x minus 4. This is not the square root of x minus 4. Here you have to write x minus 4 greater than or equal to 0, but here only x greater than or equal to 0. 4 has nothing to do with the square root. The 4 or negative 4 is not under the square root. So you cannot include it all of a sudden. So then the domain is 0 to infinity for this function. An interval notation, bracket 0, comma, infinity, and parenthesis. Type your answer in interval notation. So why are these red? I have no idea. Graph. So remember what this is. You have to remember that list of functions that I gave you. So this is the square of x, and this pulls down the graph 4 units. So 1, 2, 3, 4. So this is the graph. We discussed these transformations. It pulls down the graph 4 units. Yes, you can graph it with a graphing calculator. This is nonsense. This is nonsense. This is nonsense. This is the only one that pulls down the graph. And the range from the lowest y value, from negative 4 up to infinity. So bracket negative 4, comma, infinity, parenthesis, and we move on.
I don't know why, but during the test, on all of the questions that had that, I flipped domain and range. I don't know where my brain went in that moment, but you can literally see I got them right, but I flipped them. Like, I put the range where the domain should be, so I got it wrong, obviously, but I don't know what I was thinking.
Okay, we can take a look at it. This one, it's another blink type of problem. Why? Of course you will simplify. You learned that from me by now. So z squared equals 25, and then another blink to write z equals plus or minus 5, and you're done. Because we take the square root. This is a typical situation for taking square roots. Good. The next one. So here I have negative 5, comma 5.
This is the one where I forgot to carry the square root with me.
So then we have 3, x plus 9 squared minus 19 equals 38. This is typical for taking square roots, but it needs prep. It needs 19 to the other side and then divide by 3. So first of all, this. So that's, what is it, 57? Now I have to divide by 3. And I get, what do I get, 19? And now x plus 9 equals plus or minus the square root of 19. And then x equals negative 9 plus or minus the square root of 19. Yes, this required, let's say, 2 minutes, maybe 3 minutes. So the steps here are clean it up first. You have to move 19. You have to divide by 3. And when it's completely cleaned up, then you think, okay, which method? I have 4 methods. Which method do I apply here? The answer is it's ready for taking square roots. So negative 9 plus the square root of 19. And then outside, comma, negative 9 minus the square root of 19. And move on. Okay, so completed the square. Yes, well, let's subtract 29, that's fine. The middle coefficient is negative 4. Second step, we divide this by 2. We square negative 2. And this is what we add to both sides. So plus 4 and plus 4. So r squared minus 4r plus 4 equals negative 25. Now, if you did not pay attention and you didn't study as I asked you to, the factoring procedures, then you may get stuck here. Because this binomial squared is a trinomial. The first term squared minus 2 times the first times the second plus the second term squared. And now we can take the square root. So r minus 2 equals plus or minus 5i. And then r equals 2 plus or minus 5i. So for this one, I will also add 4 points. Depending on, so till this point, you had no difficulties. From here on, we discussed this today, and I consider it my fault. And it is my fault. Not that I consider it. And I apologize for that. So, I have 2, and then minus 5i, and then comma, 2 plus 5i.
So, on this question, if you look at the text under it, it does say using radicals and I as needed. That was my hint. I was like, I guess that means imaginary. So then I was like, oh. All right.
Yeah. So since, as I said, they made a change and I wasn't aware of it, I thought that the answers will only be just real or not. But when I talked to the coordinator, I said on Monday night, she said, no, we made the change. Okay, fine. So I considered my error and I will add those 6 points. Good. So the equation using the quadratic formula. Okay. So I have to set it equal to 0. 6x squared minus 2x minus 2 equals 0. And I hope you remember that always clean it up, always. So I can divide by 2. Never solve a quadratic equation with a negative leading coefficient. Please don't. So 3x squared minus x minus 1 equals 0. And now we are ready for the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. And this is it. meaning 1 plus or minus the square root of 13 divided by 6. So again, this is a 2-minute problem maybe. So we enter it as a fraction, and then at the top 1 plus or 1 minus the square root of 13. And it's divided by 6. And then comma, the same thing with plus. Divided by 6. Good. Determine the discriminant. We cannot determine the discriminant before we, so this was the extra credit. So I added 9 points to your test grade because this was extra credit if you did it correctly. So 2w squared minus 3w plus 7 equals 0. So the discriminant is b squared minus 4ac. B squared is 9 minus 4 times 2. 56. So this is a negative number. You don't have to do anything else. So negative b, b squared minus 4 times 2 is 8, minus 56. So this number is negative, I'm sorry?
Negative 504. Wait, isn't it 9? Oh, 9 minus 2. Oh, sorry.
That's okay.
Listen to me.
I make mistakes too. I'd rather go back and check. So the discriminant is negative 47. 2 complex solutions, they're not real. This is horrible to say 2 complex solutions that are not real. If you say complex solutions, there is no need for you to say they're not real. 2 rational solutions, 1 repeated, 2 irrational. No, they're 2 complex solutions. There is no need to write that are not real. You either write they're not real solutions or you write they are complex solutions. There is no need to write both.
Out of everything that I got wrong, I got that right. Like,
Good. So here we have to determine the domain. I was hoping that no one would make a mistake on this. The domain, of course, is all real numbers. So I have to write parentheses from negative infinity, comma to infinity. The range, obviously from the lowest to the largest. So I have a bracket, and I have 0, comma, infinity with a parenthesis. The x-intercepts, I see them, negative 6, 0, and 4, 0. Type an ordered pair, okay, comma, good. So I have negative 6, 0, and the other one is 4, 0. Good. Find the y-intercept. The y-intercept is right here, 0, 9. Ordered pair. Very good. 0, comma 9. Okay. Determine the zeros of the function. We know that. In x-intercepts or zeros mean the exact same thing. Let me see if it allows me to copy and paste. It does not allow me to copy and paste. Nice. Okay. So I have to copy the negative 6, comma 0, and the 4, comma 0. Off. Good. And that's it. Okay. Let me complete my assignment. Very good. Okay, so this I have to factor out. So 8 and x plus 5 and x plus 5 and x minus 5. And we simplify. So it's 8 over x minus 5. I didn't think it would allow me to go back. Okay, fine. Okay, and I just, did they give me a different problem? Or we have the
That's
end?
the same one.
Was it the same one?
Yeah, it's a 1/3R.
I thought so. Yeah, 1/3R. Good. Okay, let's see what I entered incorrectly. Okay, so now it allows me to submit it. Let's see what I entered incorrectly. Which problem? Okay. And 9. Okay, let's see what I did here. Does it allow me to open it? Let's see.
I think it's because you put order pairs and not.
Oh, I didn't read the fine print. Wonderful. Okay, good. So please don't do that. Don't follow me on this one. Oh, see, that's the reason why I put the answer, the simplified form, but it says the square root is not a real number, which we knew. We wrote it here. Why do I have to write it twice? But I did not, again, read the fine print because it said type an integer or a decimal. Well, this is not an integer and it's not a decimal. So that's why I was supposed to click on the square root is not a real number, but I didn't.